So welcome back. In this tutorial I will show you how to use the worksheet that is called SHM for SnappyHexMesh, so you can easily create your dictionary file for SnappyHexMesh. What we need first is we need a geometry that we want to mesh, and in this case I will just create a simple box just for demonstration purposes. And what we need to do is we need to export this as an STL file, obviously. But before I do that, I will just create a new directory that I will work on. So create new, and I already did set up a directory for that. So let's go into that, hit that, select and like box test as a project name. What you will see now is you have a directory and a constant directory which is empty, system directory which contains the control dictionary and the compose part dictionary, and the foam file, so you can view it in ParaView or in the mesh viewer inside this. So after setting the path, what we need to do is obviously we need to generate the SnappyHexMesh dictionary file. So the first thing I'm going to do is obviously I need to export this one, right? So right click, export, and this geometry is from the object tree. I need to select this one, or if I have multiple ones I can select all of these, and what I need here is geometry dictionary, so I can copy the path, enter it here, and I want an ASCII file format and medium resolution. Resolution does not matter right now for this simple case. When I hit export, you will see that the STL is generated pretty quickly. So if you hit this button, you will be able to select all the files from the object tree. It will create the list. So I will hit this one, hit OK. Alternatively, if I don't have any connection to the object tree or I work with external files, I can go here, hit new row, or select this row, remove row, remove row. So this is just for convenience purposes. So what I can do also is, if I want to reset everything, hit that. So this is a reset button, pretty easy. If I have saved the file and I want to work on that, I can hit the load button, and then you need to select the file. Well, let's just do that. I hit on that, and you see here right in the left bottom corner, file is saved successfully. So it will create this JSON file. It is human readable, so you can open and read it. And actually we can just let's name it box, and let's save it. Okay, that is now saved. And if I reset this and I load it back, it will automatically load the JSON file. So reset again, and I will import this box. So remember, we did export an STL file that has the name box, and the geometry name is called box, and you don't need to type the .stl after that. So this will tell you to include the geometry or not. So if you have like multiple ones, and you can just uncheck these, and what you will have is you won't see this geometry in the SnappyHexMesh file. So let us leave it there right now, and let us talk a little bit about the background mesh. So this will create the background mesh. This is colored in red. Once you export your background mesh, it will turn into green. So check this show background mesh, and what we need is to create a bounding box, obviously. And you can type in the coordinates by yourself or hit that bounding box, and it will automatically take that bounding box of the geometries on the viewer, and then it will expand by factor 1%. You can also expand by factor like 2 or so, and then hit bounding box again, so it will update, and then hit apply, and you will see the bounding box. And right now I have a cell size of 5. The length of the box is like 10, so I can also change the view setting for the background mesh, and if I have surface mesh, it will show you exactly what the size will look like. So let us turn that into something like 2 and apply, and you will see that. Now as for patches, you can rename the patches. Okay, Xmin, Xmax, you can put like inlet, outlet, wall, whatever you want. You can change the from patch to wall the boundary type, and you can export the block mesh dict, or you can export the mesh directly. It will just generate the file for you. So I think we can go like 1 as okay for this purpose. So I will export, and it is really that fast, it export. So I will go to that directory and camera check mesh and verify. Okay, so you can also drag and drop, accept, and this is your background mesh. So clean your state, and okay. So once we export the background mesh, what we do next is we need obviously a material point to tell where the inside of the background mesh we will keep, and the rest will be discarded. So hit show sphere. The radius of the sphere is like 1, which is too low to see, so hit 5 or something like that, and hit OK, and you will see the sphere appearing here. Just hit the attach detach gizmo, and it will create this. And you can turn around, and if you're happy with where the material point is, you can just, the radius is irrelevant, it's just for you to see. So accept and close, and it will remain there. So hide, accept, close, and that will turn into green. Here we did export directly, I think, when I hit export block mesh dict, which does export the dictionary file. It will turn into green. So we have set up everything. So as for the settings, normally you will see all these settings I have here in the dictionary file. Okay, we have the castellation and snapping settings here, grouped in castellated mesh controls, snap controls, layer controls, and this is the mesh quality control. And obviously I have debug flags. So I will leave that as it is, so because it is just demonstration, and for each case you will probably need to fine tune according to your needs. So what you can do here is you can, each icon stays for one step of the SnappyHexMesh phase. So this is the castellation step. The icon shows the mesh, and in red the ones that are outside of the domain that we want to remove. This is a snapping. So you have here body conformal mesh. After the snapping, this is obviously the boundary layer, and this is the button to enable or disable the quality check control. So you can click on each of these and it will just tell SnappyHexMesh to include or ignore this step. Okay, so I will not create any boundary layers. For example, I can hit this, and in the step I will not check any for any controls. So if you don't want to snap right in the step, so you can ignore that also, right? So what we need additionally is obviously future edge. So I can in the bottom section here you will see the surface features dictionary. I can hit that and it will automatically generate this file. So surface feature extract dict. I think the ACI version uses one of these and the other one is used by the Prefoam org version. So the next thing is I can also show you one feature of this software. So let me hide the background mesh. Now you can create the eMesh file by yourself. Just click on this add button and it will click create a new entry. Let's call it box. And once you do that, you can look here. The number of edges that are attached to the box are 0 and number of points also. So you can select the box and then hit that and it will automatically extract all 12 edges, and these are also highlighted. And if you hit discretize and look at the what is discretized, you will see these dots and you can export these and it will automatically generate the file for you, the eMesh file. Or alternatively, let me delete that. We have the surface extract dictionary. So surface features extract. Extract. Okay, let's use surface features. Okay, it just created the eMesh file for us again, as you can see here, but this time it used the internal dictionary that we created by exporting, by clicking on this one. So I can hide this, delete this. As for the settings, for each STL file we can choose like what type of boundary we want, like wall, patch, or we can also use STL files for refinement zones. And if I click on that, you won't see any patches created from this. It will exclusively either use for refinement. If you like have a car and you want to resolve the wake, you can just hit the refinement from the drop down menu, or you can declare it also a zone. Okay, like if I want to create a refinement out of this box, I hit this and you probably want to refine inside, and by the level you want you can select just now region is none, so for refinement. Now feature edge, if you have the eMesh file created with this tool and you have like renamed it not box or something else like box edges, you can just import like this, like box edges or something like that, box edge, and you can create feature edge and your level, and then this is distance, as you can see from the information it will tell you. So we will go with the box let me call it wall, and let me call here are two entries, right? So min-max surface refinement levels, min-max. Let's do one level on refinement. And as for the region, we said we don't want declaration of region. We want to, now -1 means we will not snap to the feature, so it will get ignored, the mesh file, but in this case we definitely want to snap. So 0 means snap. Everything else like will enhance the level. We can just for demonstration purposes, because we refine the surface by level 1. Let us take level 2, and then this will be the distance. Let's do like 2 or something like that. And as for phase zone, that would be some relevant if I would select the refinement zone. As for the inflation settings, I will uncheck that, or I will create, okay, so let us set the name wall, and I want 3 layers. These are general settings. You can override these with local settings, so this will enable and disable. So relative size, let us just put that like 1, and just for demonstration purposes, relative size is on, expansion ratio like 1.1. So I think that's everything we need. So once we are done here, let's click SHM, and it will create the SnappyHexMeshDict automatically. You can read it, open it, read it, no problem. So let us run that tool now. Hopefully it does not take long, so we can. Okay, so that's okay. So as you can see, it created multiple files here. So if I select this, select as you can see, this first step is castellation, right? What we did is we declared as surface refinement level 1, so it will do 1 refinement, and in the edges we said we want 2, and then this would be the snapping step. Well, you probably won't see much because the geometry is aligned pretty good. I think here you will see, let me just go back and look at these sections here. From one level to the other, you will see that you have change here. So the next step would be like the boundary layer step, and as you can see, because I did take in the settings, it was like relative sizes, and the relative size here is level 1. So it will look like this. If I don't want any boundary layers, I can switch off from here. Okay. So I think I covered in this video the most important settings. Okay, if you need to change anything from here, change it. Don't forget to export before you use it, and don't forget to save your settings so you can use it later. Maybe you can load your file again if you need to create with the same settings but different mesh sizes. You can actually open the JSON file. It is human readable. It is a bunch of setting files that are read and written. So thanks for watching. If you have any other requests, like meshing something that is more complex than this simple case, you can just write in the comment section. And for now, thank you for watching.